Greetings and welcome, friends. Mr. Wadi here. Me and mis amigos, we were talking about like volume of pyramids and stuff. Here we go. So an interesting outcome of the volume of any pyramid, regardless of the base, was that it kind of had like this 1/3 find the area of that base, multiply by the height. And what's really intriguing is it didn't matter what the shape of the base was. It could be like a pentagon, a rectangle, all sorts of crazy things. That's just like a sad-looking pyramid right there. But here we go. More interestingly, I jumped right to this type of problem where we know the volume, but we don't know side length. So this is a rectangular-based pyramid. All right, so let me see if I can draw a rectangular base pyramid here. Now, question, would it matter if the vertex was directly above the center of the base or not? No, we could have what's called an oblique pyramid, where this vertex is kind of like all crooked and sideways over here, and it wouldn't even matter. It would still actually have the same volume as long as the height of that is the same. All right, so there's my pyramid. Let's label some stuff. I know the volume is 480. All right. Cubic inches. The height is 10 inches. Right, Lauren, thank you. The width is 9. And then there's some unknown length. Okay? So because it's a rectangle, the area of the base is base times height of a rectangle. So the area of this base is just going to be 9x. Multiply that by the height is 10. These are all in inches, fortunately. And, oh, I'm already, man, whatever. And then it's 1/3 of that. I would also, and I wrote A. Oh my goodness, guys, that's so embarrassing. Mr. Wadi. Mr. Wadi. We're talking volume. Right, there we go. And the volume is 480. So I plug in what I know, solve for what I do not. Let's simplify this. 1/3 of 9 is 3x times 10. 3 times 10 is 30, so 30x equals 480. Divide both sides by 30. And then I can just algebraically, systematically solve this for my unknown dimension. Zeros cancel out. How many times does 3 go into 48? 16? All right, so my rectangle is not to scale, and this would be in inches. So there you go. No es más mal, right? 1/3 the base times the heights. Good times. So, find the height of the pyramid. So this time I don't know the height. This is a triangular base. Fortunately, it's a right triangle base. So the volume, 198, is going to equal 1/3 times the area of the base. The area of a triangle is 1/2. It's lowercase b base times its height. All right, these are all in yards. Those are yards cubed. Fortunately, there's agreement there. Multiplied by my unknown height. 11 and 9. The area of a triangle formula is 1/2 the base times the height. Right? So let's see. So 1/3 times 1/2 is 1/6. Or actually, let me just do 1/3 of 9 is 3. I'm going to have 3 halves times 11 times h. Looks like 33 halves. H is what I end up having here. So Alyssa, I'm going to multiply both sides by the reciprocal here. 2 33rds. 198, that feels like that's divisible by 99. So 33 goes into that 6 times? Is that right? And then 6 times 2 is 12? Did I do that right? Yards? Do I have confirmation from anybody, or? Maybe my cancellation might not be right. 198 divided by 33 is 6. 6 times 2. Yeah, this is right. If you got... make sure that that if you were using area of a triangle formula that you did half the base times the height? See, a third 3 over 2 times 11. Lauren, Malik, quiet please. Anthony's talking. Because the triangle, yeah, it depends on the base polygon. Yeah, I did 9 divided by 3, and I got this 3. Well, I don't distribute multiplication over multiplication. If these were plus signs, then I'd have to. But you can change the order in which you multiply things using the commutative property. I think I got it right. I don't know. The internet will tell me. All right. Ooh. So the scale factor, K, between these two is going to be 3/12 or 1/4 is my scale factor of the linear dimensions between these pyramids. Okay? That pyramid B is 1/4 the size of pyramid A linearly. So that would be in terms of its height or its width or its perimeter or its slant height, as we'll talk about today. Okay? 1/4. However, their volumes are going to be, it's going to be 1/4 all cubed. The volume. 1 cubed is 1, 4 cubed is 64. This is 1/64th the size. So the volume of pyramid B is going to be 1/64th the volume of pyramid A. Multiply that. I get volume of B is going to be, what is that? Is that 4? Man, I'm not trusting my fraction reducing at all today. Yeah, that is. 4 cubic feet. So a pyramid that is 1/4 the height will be 1/64th the volume, assuming it was similar to the original. All right, this is a good problem here. I'm going to do area of the cube. Sorry, volume. I keep saying area. Volume of the cube minus the volume of the pyramid, right, is going to equal the leftovers. Right? So there we go. So to find the volume Joshua of the cube, that's just going to be 12 times 12 times 12, or 12 cubed, which, by the way, volume of a cube and the word cubed for a third degree exponent is literally related to each other. That's where the terminology came from. So 12 cubed is 1728, right? As far as this pyramid, friends. Look at this triangle. Now that's a cube, so this is a right angle here at a perspective. This is an isosceles triangle whose base angles are congruent. Let me draw this triangle zoomed in. So I know this, this, and this. Therefore, base angles theorem, the triangle is going to have congruent acute angles for that right triangle. And it is a 45, 45, 90 triangle. What is the leg length on this triangle? 6, because this was connecting the midpoints and those were labeled as congruent. So that is 6. And to go from the leg to the hypotenuse of a 45, 45, 90, I multiply by the square root of 2. So this is 6 rad 2, 6 rad 2. And how high is this pyramid? 12, right? It's the same as the height of the cube. So, as far as the volume of that pyramid, it's going to be 1/3 the area of the base, which is 6 rad 2 squared, because it's a square, right? Multiplied by the height being 12. All right, 1/3 of 12 is 4. 6 squared is 36. Root 2 squared is 2. Right? So I'm going to have whatever 72 times 4 is. What's, man, 72 times 4, 288. And then 1728 minus 288 is going to be 1440 inches cubed. So these composite volumes, you just do volume addition postulate, right? Little area plus little area equals, sorry, man, I just said it so wrong. Little volume plus little volume equals big volume, and then you could, subtract and find what you need. Thanks for watching, Internet friends. Have a great day.